Hello, everybody. Shelby and Miss Cross are here for Science, Day 3 of Digital Learning. Hopefully you've been able to find some stuff around your house to do some of these science investigations. I am going to read a book to you, and throughout the book we're going to stop and demonstrate a few different sounds of ways we can see and hear sound. So, you might have some of these things at home too. One of them is a musical triangle. You've probably seen that in Miss Blanchard's class. Now, we didn't have one of those, but we did have the tuning forks we brought home. You might even have some metal spoons or cooking tools. Those would work. If you have a drum, a toy drum, we didn't have that, but we had these that we made the other day for the other investigation. Just a bowl with plastic wrap, a bowl of water and a rock. And we have some rubber bands. Also something that could be used as a megaphone, something that makes sound louder. We have this little toy microphone. You might even have a paper towel roll or toilet tissue roll. That would work. So as I read, I'm going to stop and let Shelby demonstrate some of these things to you. This is our book for today. Loud, soft, high, and low. Sound. All right. How are sounds made? A baseball smacks against a wooden bat. Thwack! Raindrops tap against your window panes. Pitter patter, pitter patter. How are sounds made? Tap a musical triangle. You can see it shake. As the triangle vibrates, it makes sound. Sound is made from vibrating things. And we're going to show you that in just a second. But you can even do this with your own body. If you put your fingers right here on your vocal cords and hum. You can feel that vibration. And I just realized I forgot one supply. While Shelby shows you the tuning fork on a bowl, I will be right back.
Okay. So I'm going to do the... Okay, so I have the tuning fork. I'm just going to hit it on the side. It vibrates.
All right, you can hear the sound from the vibration. Now, Shelby doesn't know what I'm about to ask her to do, but it's going to be good. So, Shelby, I want you to take a little bit of water from this glass cup and put it in your mouth like you do in the morning after you brush your teeth, and then you're going to gargle it.
Okay.
Turn your head back and gargle it. So she used her throat to vibrate the water, and you can do that with water or mouthwash, and you can feel what it feels like inside of your throat. Okay, thank you, Shelby. All right. Throw a pebble into a pond. Watch how the ripples move away from the splash. Sound moves in waves like ripples in a pond. Sound waves move in all directions from a baseball bat, a raindrop, or anything else that makes sound. The waves travel through the air to your ears, but you can't see them. Sound waves are invisible. And remember, sound waves move out away from whatever is vibrating. All right, so we're going to see if we can get the right camera angle here. All right, Shelby, drop the rock into the bowl of water. You can see the water making waves, and that is how sound moves in waves just like that. Okay, what makes an echo? Stand inside a big empty room. Shout your name. It sounds as if someone is saying your name back at you. You have made an echo. Echoes are made when sound waves bounce off big, hard things, like walls or mountains. When sound bounces back to you, you hear it again. Here's a fun fact. Bats use echoes to find their way through dark caves. As bats fly about, they make squeaky sounds. They listen for echoes to tell them where the cave walls are. How cool. All right, so we have this little toy microphone Shelby's going to demonstrate, and her voice, hopefully, is going to echo.
So say,
La 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 la.
la 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 la.
Do it louder.
La 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 la.
Ba 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 ba. You can hear our voice bouncing back. The sound is echoing. All right, Why are some sounds loud and other sounds soft? We talked about this a little bit last week. If we throw that pebble hard into the water, it makes big waves that travel really far. If we did it in a lake and threw it really far, those waves would travel very far away. If we bang a drum, Shelby, hold your drums over here, it makes big sound waves that travel far. So this is our little pretend drum. Oh, that didn't sound very loud. We'll try the bowl. There you go. So the harder she hits it, the stronger the vibrations are and the louder the sound is.
Let's try this one again.
Try the other one again? Okay. Oh, you can hear the vibrations. It would probably work better if we had a real drum. Some of you might have a real drum. Here's the page there. So if we tap the drum lightly, it rumbles softly. The sound waves are smaller and they don't go as far. So the bigger the vibrations, the bigger the waves, the louder the sound, and the smaller the vibrations, the quieter the sound. Sometimes a sound is loud because you are close to it. A whisper can be loud and clear if your friend is standing right next to you. The roar of an airplane sounds soft when it is far up in the sky. But if you were up close to that airplane, it would actually be very, very loud. Loud sounds are sometimes helpful. Alarm clocks buzz and wake us up, and sirens yell when danger is near. You can make a sound seem louder or softer. Put your hands over your ears, and a sound seems softer. Cup your hands around your ears, and you can catch more sound waves, and the sound seems louder. So you can even do this yourself. If you put your hands flat on your ears and talk. Shelby, try it. What does your voice sound like?
It sounds actually lower.
It sounds really quiet. Now do this. Cup and talk.
La la la, I can hear.
La la la. Ba ba.
La.
Try it loud. If you try that, the sound bounces and your hands are able to catch more waves, so it is louder. So the difference between covering your ears and cupping your ears can change the volume of the sound that you hear. Here's another fun fact. Builders think about sound when they plan buildings. Some places, like libraries and hospitals, are built to be more quiet. Other places, like concert halls, are built so sound resounds or echoes, so it's louder and stronger.
When you do this to your ears,
Everything sounds louder. Why are some sounds high and others low? Pluck the thinnest, tightest string on a guitar. You can see it vibrate very quickly. Listen to the sound it makes. Things that vibrate quickly make high-pitched sounds. So we just happened to borrow Mr. Elliott's guitar, which neither of us know how to play. And that's the wrong way.
Oh, yeah.
That's fine. There you go. Okay, so she's going to pluck the smallest, tiniest...
That's not the right way. That's not the right way.
Yes, it is. Come closer. All right, this might be hard to see, but pluck the small, thin string at the bottom.
Wait.
I know it's hard for you to see, but when she does that, it vibrates really quickly. Do it again. Okay, good. Now do the thick...
Wait, no, they can see it right here.
Yeah, you can see it a little bit. Now do the top one on the thicker one. Okay, that one vibrates more slowly and the sound is lower. Do the little one again. You can't even see it, it vibrates so fast. Now do the big one. Okay, good. Now, thank you, Shelby. If you don't have a guitar at home or a ukulele or something like that, you might have rubber bands. You can play around with making the vibrations. And I have some different size and different width rubber bands, and we can pluck these. It's good to see the vibration. You can see them vibrating. Here, try the skinnier one. Doesn't make much of a sound, but you can really see the vibrations very well. The thickest string on a guitar vibrates more slowly and makes a low-pitched sound. Now you know all about sound. Loud, soft, high, and low. What kinds of sounds can you make? What's the highest sound you've ever heard? What about the lowest sound you've ever heard? Or you can also think about the quietest sound you've ever heard or the loudest sound you've ever heard. All right, so this is the science work you're going to do today. You're going to log into your e-class, and before you click onto your course page, on that first page, thank you, Shelby, you're going to click on the STEM Scopes link, and you are going to work through the picture vocabulary, the STEM Scopedia, and the reading science, which is called a guitar lesson, and those are under the sound and vibrations scope, and they should already be assigned to you. If they're not, just message your teacher and let her know, and we can get that fixed for you. Now, this is a challenge that I would like to issue to all of you scientists at home. If you would like to, by Friday, or even by Monday if you need the weekend, I challenge you to create your own musical instrument at home. Now, this might sound hard, but really you can do it with very simple things around the house. If you have your parents' permission, go on Pinterest or on Google and search for DIY musical instruments or musical instruments for kids or craft musical instruments. There are tons of ideas. A lot of it you might have already in your junk drawer or in your recycling can outside in your garage. You might even have some in your room, in mom's craft room, in the basement. You could have stuff anywhere that you could use. So, I hope you have fun investigating sound. You can gather some of the things like we had here today and try some of these at home. You might think of another thing that you can demonstrate sound the same way we did, but with a different material. So have fun with science. Let us know if we can help you, and we will see you really soon. Bye.